All right, today we're going to talk about sets of numbers, section 1.1. Yeah, you can. I know you're getting your iPads here this week, hopefully today or tomorrow. So if you wanted to, you don't have to write down like all the vocabulary and everything, but just kind of write down some of the essential example problems and stuff, and you'll be fine until you get your iPads.
That's what's on the test.
Yeah.
All the examples that are in here.
A lot of times. But sets of numbers, section 1.1. Okay. First thing we're going to do is talk about some of these vocabulary terms. Again, don't feel like you have to write down all these, as you are going to get your iPad here soon, and everything will come up here on your iPad. But first thing we're talking about is a set. A set is a collection of items called elements. For example here, the set of numbers 1, 2, and 3. Those are numbers within a set. I could also have the set of numbers 2, 4, 6, 8. That'd also be a set of numbers. So it's just kind of a numbers within an arrangement. Element of a set is an item in a set. For example, the number 1 is an element in the above set 1, 2, 3. If I look at my even set here, what's an element within that set, O'Connor? What's an element in that top red set? 2. Yeah, 2 is an element within that set. 4, 6, and 8 are also elements of that set. Okay? A subset. A subset is a set that is contained entirely within another set. So taking my example here, 1, 2, and 3, a subset could be 2, 3. That is a subset because both of those are contained within the set 1, 2, 3. Those are subsets. What's another example of a subset you could do there in 1, 2, 3? Tell you what's another subset you could do.
1, 2.
1, 2. Yeah, that's another subset. There's multiple subsets you could always choose. Empty set. If it's empty, what's that tell you there?
Nothing.
Nothing there. So empty set is a set with no elements. So the empty set is nothing there. Roster notation. When you think of a roster, what do you think of? What? Team. Okay, what else do you think of? What's on that roster usually?
People.
Names. What's more important? Everything is what? Organized or listed out. I was thinking of. Everything's kind of listed out. You probably put numbers, right? You have your jersey numbers, you have this stuff. Everything's listed out. So in a roster notation, it's a way to represent a set by listing the elements between braces. So everything's kind of listed out. Okay, so the first 5 positive odd numbers are 1, 3, 5, 7, 9. That is roster notation. Everything is listed out. Next thing we're talking about is a finite set. A lot of times we don't know the word finite, but we know what the word infinite is. What does infinite mean? Infinity, it goes what? It goes on, never ending. Perfect word. So what does finite mean? It has an end. So a finite is a set with a definite or a finite number of elements. And I missed my bracket here. So finite means there is an actual end to the set. So 2, 4, 6, 8, 10. The set ends. Okay? It has a beginning, it has an ending. An infinite set is a set with unlimited or infinite number of elements. For example, the set of all integers is an infinite set. Okay? So it keeps going on and on and on and on in both directions. Okay, it's an infinite set. Interval notation. We're going to be doing a lot of interval notation today. Okay? Interval notation is a way of writing the set of all real numbers between 2 endpoints. The symbols here, these are what we call brackets. The brackets are used to include an endpoint in an interval. All right? So brackets are typically used when I have less than or equal to, greater than or equal to, or I have what's called a closed or filled in circle. Parentheses are used to exclude an endpoint from an interval. So parentheses are used when I have like less than, greater than, or in an open circle. And we'll look at that when we get to an example and make more sense. Okay? But interval notation, brackets and parentheses are kind of the keys there. Brackets, the numbers included. Parentheses, everything up to that number is included. That number is not included. And then set builder notation is a notation for a set that uses a rule to describe the properties of the elements We'll look at some of these. For example, if you were to look at that right there, how would you say that, Allie? What's it in parentheses there? Actually, just, or sorry, circles are there. Highlighted, right there. How would, yeah. What's that say? X is greater than 3. So step notation is just, hey, X is greater than 3. And we'll look at some of that. Yeah, it says that. All right, so these are the subsets of numbers we're going to talk about today. You should recognize these from Algebra 1, hopefully. When you were first starting in math, like in elementary school, what were some of the first numbers you probably learned? 1 through 10. 1, 2, 3, 4, 5, 6. Those are what are called the natural numbers. Why are they the natural numbers, would you guess?
They're the ones you know.
They're the ones you know. Those are the ones that came natural to you when you first learned numbers. You first started learning at number 1. Okay? Natural numbers are what's also called like the counting numbers. Natural numbers are anything that you could do to count. Okay, now he said the example is 1 through 10. It actually goes 1 almost to like infinity. 1, 2, 3, and it just goes on and on and on. But the lowest number is 1. That is the natural counting number. After you learned the numbers like 1 through 10, he kept going. What's the next number you probably learned? After all the counting numbers. After all those ones, I don't want to go higher.
1.5 decimals.
Ooh, before even their decimals. Before negatives.
Fractions.
Oh man, fractions were like way later.
Negatives?
Before that.
0.
0. Whole numbers. After you learned 1, 2, 3, 4, 5, didn't you learn about 0? Probably. Whole numbers are 0 and then all the counting numbers. So 1, 2, 3, and it goes on and on and on. Whole numbers are 0 and all the counting numbers. So our subset gets a little bit bigger. Okay, our subset gets a little bit bigger here. After whole numbers, we have integers. That are all the whole numbers and their opposites. These are the negatives and the positives. So I have -2, -1, 0, 1, 2. It goes on and on and on. So it's all the negatives and their positives. Now, rational numbers was when we got to about junior high and middle school. Got pretty rough, because that's when we started learning about, what do you say? Fractions. Rational numbers are fractions. There are, and we will get to that. Not today. But yeah, fractions, like 1/2. 0.2. Why is 0.2 a fraction? Because that's what decimals are made from, right? Decimals are made from fractions. Okay, then we have these things called irrational numbers. Who can guess what an irrational number is? There's a popular one. Everybody loves it. Pi. Pi is the most common irrational number. Okay, what's it mean to be irrational? It never ends. Yep. Pi. When you think of pi, what do you think of? A lot of people think of 3.14, right? But really, it's 3.14, 159, 276. Keeps going and going and going and going and going. Okay, it never ends. Pi is a common irrational number. Other common irrational numbers are square roots. Square root of 2. Square root of 2 is an irrational number. It goes on and on and on. It's not going to end. What about the square root of 4? Would the square root of 4 be irrational? Why not? Square root of 4 is 2. Well, that's actually a natural number. Okay, so not all square roots are irrational, but most square roots are irrational numbers. Okay? And here's an example of all those again. So there's the natural, whole, integers, rational, irrational. I don't know, at some point probably.
It's supposed to rain tomorrow too, though.
Alright, so the first thing we're going to talk about today is we're going to talk about ordering numbers from least to greatest. So as you move from left to right on a number line, the numbers increase. Hopefully you should know that. Use the number line to help you order real numbers. When you're looking to order numbers, what's something that helps you? You can identify the what first, possibly. Smallest number. What, if you're looking at a set of numbers here, for example, this set right here, what's something that pops out of you right away that says, man, this should probably be one of the smallest numbers? No? Negatives. Thank you. When you're looking right here, I would look right away at the negatives. Why? Negatives are always going to be lower. Okay, so when you're looking to order numbers, I would always look to negatives first. Okay, I have negative 2.6 repeating, I have negative pi over 2. Well, if you have to, you can use a calculator here to approximate. Square root of 11 is about 3.32. Negative pi over 2 is about negative 1.57. So as I list them from least to greatest, I can put them on a number line, or just kind of picture a number line, either way. Well, negative 2.6 is less than negative pi over 2. So we're going to go that order. And then comes 1/2, 2.354, and then the square root of 11. And I listed them from least to greatest. So whenever I'm looking to least, I'd always look at the negatives first. That will always help you out. So let's try number 1 here. I want to order the given numbers from least to greatest, use a number line to help you. As I look up here, which one should stand out to me right away, Katie? Which one is it? Yep, so which one's going to be my lowest? Negative 5 over 2. It's got to be the lowest. It's the only negative up there. Now, after negatives, before we get to positives, what number falls in place there?
0.512.
Ooh, before that. You might not see it because there's some... 0.
Oh, I saw this. I thought it was 2 blank.
Yeah. The commas and the periods kind of look a little off. Yeah, but every time you get after negatives before you get to positives, always place that 0 in there. So I have 0. Okay, now I have 0.6 repeating, square root of 2, and 0.5129. Now, which one's going to cause us troubles there?
Square root of 2.
Square root of 2. Now, does anybody in here know that square root of 2 is off the top of their head? Calculator probably does, you're right. Let's think about this, though. What's the square root of 2 greater than?
1.
Square root of 1, right? Square root of 1 is 1. So what's the square root of 2 have to be greater than?
1.
It has to be greater than 1. I know that right away because it's greater than the square root of 1. Square root of 2 is actually like 1.42 or something like that. But again, I don't have to actually use a calculator here. I can just use knowing what a square root is and knowing some other common square roots. I can figure it out without using a calculator. So what's going to come next after 0 then? 0.5129. After that would come 0.6 repeating. And lastly, the square root of 2. Nice job. Okay. What about number 2 here? As I look at it, what should pop out right away, Drew?
There's 3 negatives.
3 negatives. I have negative 2, negative 0.321, and negative square root of 3. Which one's going to cause us troubles there, Kyle? Negative square root of 3 is probably going to cause you troubles. Bennis?
I got it.
You got it. What do you got, man?
It's going to be negative 3 would be these, right? Wait, what?
Negative 2. Negative 2.
It's negative
Oh,
2.
yeah, negative 2.
And then what?
Then it's square root of 3.
Bennis.
Yeah, probably negative 3.
Then it's negative square root of 3. And then it's what?
Negative 0.321.
Negative 0.321. Okay, so though all my negatives are gone. Now I have pi and 3 over 2. Well, what's pi approximately, Hannah? Pi is approximately what? 3.14. So I know pi is greater than 3. 3 over 2. What's 3 over 2, Beast?
1.5.
That's 1.5. So I have 3.14 and 1.5. What's coming next?
3 over 2.
3 over 2. And then comes pi. Now, square root of 3. Some of you probably got confused on that one. How do I know for sure the square root of 3 is technically greater than 2 there, or negative 2? Let's think about this. What's the square root of 4? 2, right? So I know the square root of 3 has to technically be lower than 2, right? But because it's negative, that means it's greater than 2. Okay, so recognize that. Finding those perfect squares can help you identify those different ones. All right, try these 2. Take a couple seconds, or order these 2 from least to greatest. This here. So number 3. Which one would be the least one right away? Jake King. How do you know that? It's the only negative up there, right? Which one's going to come next then, sir? Yep. 2.3 repeating. And then comes?
Square root of 5.
What does the square root of 5 come out to be?
2.5.
What is it?
2.5.
It's about 2.5? Is that what it was? You sure?
Yeah, I'm not.
Square root of 5 is 2.5?
No, I just guessed.
Does anybody know what it actually is? Somebody find it for me. Square root of 5. What is it?
Is it 2.45?
Square root of 5. Anybody?
Like 2.23.
2.23. Ah, so what should actually go after negative 11 over 2? Square root of 5. Square root of 5. And then after the square root of 5 comes 2.3 repeating. And then comes 2.7652. And lastly I have pi. Yeah, don't get tricked up on those square roots. Make sure if you have to, use a calculator to find out what the actual decimal is. All right, number 4. Kyle, what do you got? Kyle.
I have negative 5.
Negative 5?
And negative square root of 2. Then 0. Then 0.5. Then 0. Or then 1.
Nice job. All right, let's look at these here. If I were to classify these numbers on number 4, negative 5, what would that be classified as? That would be an integer. Negative square root of 2, what would negative square root of 2 be? What did you say? Irrational, because we don't know what that square root is, right? That'd be irrational. 0, O'Connor, what's 0? That'd be a whole number. 0.5, Daniels?
Rational.
That is a rational number. And a 1, Blake? Natural, because the first thing we ever learned was how to count naturally. Nice job. Last thing we're talking about today is interval notation. Okay, you can represent the same set in a lot of different ways. You can use a number line to represent numbers. You can use words to represent it. We're going to focus today on what is the interval notation. Okay, now again, key to interval notation. Brackets. Brackets include the endpoints. When I use brackets, that means I'm talking about less than or equal to, greater than or equal to, or I have a filled in closed circle. I use parentheses when I have less than, greater than, or an open circle. Okay, now parentheses means the number is not included. So it's everything up to that number, but it's not included. Whereas the closed filled in circle means everything is included, even that number. Okay, and that's what we're going to talk about here. So let's look at number 5. It says 4 is less than or equal to x, which is less than 6. So remember here I have brackets, or I have parentheses. Okay? So 5 here. I have 4 is less than or equal to x, which is less than 6. When I'm looking at 4 is less than or equal to x, is the 4 included or not? Kelly, would the 4 be included or not?
Yes.
Why? How do you read that?
4 is less than equal to.
So 4 is less than or equal to. Because you have the equal to part, is 4 included?
Yes.
Isn't it like anything between 4.1?
This one's actually anything from 4. 4 is included here.
Yeah.
So going from 4 to where here?
5.
Like 5.9999999, all the way up there, as close as I can get to 6, but not including 6.
Yeah.
So I'm going to go from 4 to 6. And 6, would that be a bracket or parentheses here?
How do you tell?
That'd be parentheses. How? Well, look at this, Chow. This first part here, right? 4 is less than or equal to 6. Because it says or equal to, that means the 4 is included. So I use the bracket. It's including it. The next part here, x is less than 6. It's not less than or equal to. It's just less than. So it's everything up until 6. So that's where I use the bracket. It's excluding the 6, but keeping everything before it. So here's kind of your keys right here. Using using this identification here will help you out. Okay? All right, number 6 here. What number am I starting at here, Katie? What number am I starting at? -1. Now, if you can't tell, that's an open circle. Open circle means that it is not included. -1 is not included. It's everything up to -1, but it's not included. So that'd be a parentheses or bracket, Katie? That is parentheses. And I'm going to go over here to what number, Drew?
6.
Now, 6 has a closed filled-in circle. So 6 is included. So what am I going to have there?
Bracket.
A bracket. So it goes -1 to 6. Just like that. Okay. 7. A little tougher here in 7.
Like 2 now.
There's 2 of them here. Correct. We're going to have 2 of them. Now this one goes like this. Where is that arrow pointing to?
Whatever's on that side.
What is greater than 5, -5?
Is it just like never ending?
It's never ending. That's kind of the key there. So yeah, it keeps going past -5. What is all the way out that way, all the way to the left? If I were to go all the way positive, what would you call that probably? What'd you say? Infinity. If you went positive, you call it infinity. But I'm going negative. So it'd be negative infinity. Yeah, that's actually negative infinity. Now, is negative infinity technically a number? So can I include negative infinity? So whenever I have infinity, it's always going to be parentheses. That's pretty easy. Whenever I have infinity, it's always parentheses. So I'm going to go negative infinity to what here? McCoolidge? Negative infinity to negative, nope, right here. To -1. Now -1 has a closed filled-in circle. Is that bracket or parentheses, Jake O'Connor? That's a bracket. Or I have my next part. 2, is that going to be parentheses or bracket? Parentheses. 5, parentheses or bracket? 2 to 5. So now I have 2 sets of them here. All right? Take a couple seconds to try these 3. Number 10 might be a little tough, but try it out.
How do you do infinity?
All right, so let's look at number 8 here. 7 is less than x, which is less than or equal to 12. Prokopek, how would you write that in interval notation?
Number 8.
Yep.
Parentheses 7 is less than x, which is less than or equal to 12, a bracket.
So parentheses 7, comma 12, bracket. That's all it is.
And a lot longer.
Bennis, you got 9, you think?
Bracket, -5, comma, -2, parentheses, then 1, comma, actually all parentheses, 4.
Nice job. All right, number 10. Kelly, you think you got this one?
I might.
What do you got?
Sure. I have parentheses, negative infinity, comma, 0.
That is correct. Because if you think about it here, a lot of times I told you to think about it on a number line. Well, on a number line, what's it look like? Well, here's 0. Well, I want all the numbers less than 0, so it's an arrow that way. Well, it's going towards negative infinity up to 0 then. Okay? On the flip side, what if I were to give you x is greater than 0? How would that one be then? So it would be 0 to infinity. That'd be the opposite. Here's your assignment.
What?